Good evening students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with the exercise questions of chapter 14 Physics NCERT class 11th. Chapter name is Oscillations. Okay. So let us start with the question number 6. It says, which of the following relationships between the acceleration A and the displacement X of a particle involve simple harmonic motion? So we have to find out the four values of acceleration are given, acceleration equations are given over here, and we have to find out which of them are possessing the simple harmonic motion. Okay, so in order to possess simple harmonic motion, two things are to be kept in mind. The first thing is that acceleration is directly proportional to the displacement. Displacement can be having any variable y, x, z, but it should be directly proportional to it. Okay. Then the second thing is that acceleration is given by A is equals to minus of Kx. It is always restoring force. It is opposing that restoring force. Okay. So a negative sign is being placed over there. Okay. So acceleration is directly proportional to displacement. Acceleration is equals to minus Kx. Okay. So in the first case, A is equals to 0.7x. A is equals to 0.7x. Okay. So in this, A is directly proportional to x, but the negative sign is not placed in this equation. So the condition of A, which is A is equals to 0.7x, does not show simple harmonic motion. Okay. So the A part does not involve SHM. Okay. Then the second part again, A is equals to minus 200x square. So in the second part, A is directly proportional to x square, which is not the condition of SHM. The condition of SHM is that it should be directly proportional to the x or y or the displacement, you can say. But here it is proportional to the square of the displacement. So here also it does not involve SHM. Okay. Does not involve SHM. Now the C part. In the C part, it is A is equals to minus 10x. That is the appropriate condition. Both the conditions are satisfied. A is in the form of minus kx, which is the basic equation of SHM, and A is directly proportional to x. So it involves SHM. Okay. So A is equals to minus 10x involves SHM, which is my simple harmonic motion. And the D part is A given A is directly proportional to x cube. So it is also not involving any condition of simple harmonic motion. So does not involve SHM. So does not involve SHM. Okay. So in this way, we need to find out what equation of acceleration and displacement, the equation in the acceleration and displacement is showing simple harmonic motion or not. Okay. Now the next question, eighth question says a spring balance has a scale that reads from 0 to 50 kgs. Okay. The length of the scale is 20 centimeter. A body is suspended from this spring when displaced and released. First it is displaced and then it is released. Okay. Released oscillates with a period of 0.60 seconds. Oscillates with a period of 0.60 seconds. What is the weight of the body? So we need to find out what is the weight of the body. Okay. So what we'll finding out over here? We need to find out the weight. Now weight is equal to mg. Okay, weight is equal to mg. So first we need to find out the mass. So here we are given given to us the mass the body suspending. Okay, so the mass we are given here with is equal to, it is reading, the reading is given from 0 to 50 kgs. Okay, so reading is 0 to 50 kgs. So our M is equals to 50 kgs. Then the length of the spring is equal to 20 centimeter, which will be equal to 0.2 meters. Okay, then we are given here with the time period of 0.6 seconds. Okay, so we know a condition that mg is equal to KL. So from here we will be finding out the spring constant K. K is the spring constant. So from here we will be finding out. So K will be equal to mg upon L. Okay. So M we will be putting 50, G we will be putting 9.8, and L we will be putting 0.2. The point gets cancelled, and 2 ones are 2, 2 fours are 8, 2 nines are 18. Okay. So here we will be getting the spring constant will be equal to 2450 Newton. When we will be multiplying 49 by 50, we will be getting 2450 Newton. Okay, it is our, Newton per meter. Spring constant, the unit of spring constant is Newton per meter. Okay, now we will be applying the formula for the time period. The time period formula is given by T is equals to 2 pi under root capital M upon K. Okay, so capital M, we will be finding out the capital M, and the weight of the body is given by mg. Okay, weight of the body is given by mg. Then we will be substituting the value of m in this W is equals to mg, and we will be multiplying it by 9.8, and we will be getting a answer. Okay, so let us put down the values, all the values let us put down. So T is equals to 2 into 3.14. Okay, T we have been given to us as 0.6 seconds. So 0.6 is equals to 2 into 3.14, and M we need to find out, and K we have already been find out, 2450. Now squaring both sides. Now we will do squaring both sides. Okay, squaring both sides. So when we will do squaring, then here we will be left with 0.6 into 0.6 is equals to 2 square into 3.14 whole square into m upon 2450. Okay, so from here m, when these multiplication term digits 2 square and 3.14 square will go on that side, then they will become they will go with the division, okay, over there. Okay, and this 2450 is in division over here. When it will go on the other side, it will get multiplied by 0.6 into 0.6. So my m will be equal to 0.6 into 0.6 into 2450, okay, and upon 2 2s are 4 into 3.14 into 3.14. So my value of m will come out to be 22.3 kgs. 22.3 for approx 22.34 kgs. Okay, then because in my question it is said we need to find out the weight of the body. Okay, what is the weight of the body? So weight is always being acted downwards. Okay, so because of the downwards, weight is equals to mg. Okay, so W will be equal to weight of body will be equal to capital mg. Okay, so it will be equal to 22.34 into 9.8, which will come out to be 218.93, which will come out to be 21893 kgs. Okay, oh sorry, Newton. So this is my answer. Okay, so ultimately I am left with this my answer. Okay, now a spring, let us start with the question number 9. It says a spring of force constant 1200 Newton per meter is mounted on a horizontal table. Okay, a mass of 3 kg is attached to the free end of the spring is pulled sideways to a distance of 2 centimeter and released. Then what is the frequency of oscillation? So let us draw the diagram. The diagram is shown. The diagram is somewhat like this. Spring is attached and mass is at the free end. Mass is at the free end. Okay. So this mass force constant is given as 1200 to us, Newton per meter. So this mass is first pulled and then released. First it is pulled and then it is released. So we need to find out in the part A the frequency. What is the frequency oscillation of the mass? Okay. So for that mass, what is the frequency? We need to find out. So in order to find out the frequency, we already know the time period is given by 2 pi m upon k. Okay. So the frequency will be equal to 1 upon t. Frequency will be equal to 1 upon t. So my formula will become 1 upon 2 pi under root k by m. K by m. Okay. So when we will be substituting the values, f will be equal to, this is A part. Okay. So when we will be substituting the values, we will be getting 1 upon 2 into 3.14 under root k. K value is given to us as 1200. K value is given to us as 1200 and mass is given to us as 3 kgs, 3. So it will get cancelled and we will be getting over here 1 upon 2 into 3.14 into 20. Okay, so we are left here with this, and when we will solve it, we will be getting over here frequency will be equal to 318 per second. 3.18 per second. Okay, when we will be solving it, we will be getting 3.18 per second. So we are done with the first part. Now let us start the second part. The second part says we need to find out the acceleration, that to maximum acceleration. We need to find out the maximum acceleration. So maximum acceleration is given by r omega square, where omega is the angular frequency, and it is given by 2 pi f. Omega is always given by 2 pi f. Omega is always given by 2 pi f. Okay. So we will be substituting in the place of omega 2 pi f. So we will be getting A max will be equal to r 2 square pi square and f square. Okay. So r value we have been given to us 2 centimeter. So we will be converting it into meters. 2 centimeter will be equal to 0.02 meters. Okay. 2 centimeter will be equal to 0.02 meters, because we are taking the SI values of the SI in the SI unit. So in the SI unit we have to convert it into meters. So let us put down the value over here. So the value will be equal to 0.02 4 into 3.14 into 3.14, okay, into f is 3.18 into 3.18, okay. When we will be multiplying all these values, we will be getting over here as maximum acceleration to be equal to 7.98 meter per second, okay, meter per second square actually, okay. Okay, so we'll be getting over here 7.98 meter per second square. Okay, now the C part. In the C part, we need to find out the maximum speed. So maximum speed is given by V max. It is equal to R omega. Okay, R is equal to 0.02 omega. Again, we will be substituting 2 pi f. So 2 into pi is 3.14 into f is 3.18. When we will be multiplying all these values, we will be getting 0.4 meter per second. Okay. When we will be multiplying all these values, 0.2 into 2 into 3.14 into 3.18, we will be getting the value 0.4 meter per second. So in the first part, we have to calculate the frequency. The frequency is equal to 1 upon time period. Time period is equal to 2 pi m upon k. So when we will do 1 upon t, we will be getting f is equals to 1 upon 2 pi under root k by m. We have substituted all the values over here. So we will be getting 1 upon 2 pi value. We can take 3.14, or we can also put 22 by 7. Whatever value will be putting, we will be getting the values approximately. No change will be there in the answer. Answer will be calculated by any value of taking pi. Okay. So this is the first answer, where the frequency comes out to be 3.18 per second. Okay. Then the second part, we were asked to find out what is the maximum acceleration. So maximum acceleration is given by r omega square. Omega is equals to 2 pi f. So it will be equal to 2 square pi square f square. So r value we have placed here, we have converted into meters. So it will be 0.02. 4 into 3.14 into 3.14 for pi square, and for f square 3.18 into 3.18. When we will multiply all these values, we will be getting over here 7.98 meter per second square. Meter per second square is the unit of acceleration. Okay, then the maximum speed. Maximum speed is given by r omega. R value is equals to 0.02, and again in the place of omega, we will be putting 2 pi f. So 2 pi f, 2 into 3.14 is the value of pi, and frequency we have already been calculated in the first part, so that we will be putting over here. So ultimately we will be getting the V max to be equal to 0.04 meter per second. So this is our answer. So in this way, we have to proceed for all the numericals relating to this time period, frequency, relating to the spring balance or spring, anywhere where the spring is coming, it is possessing the simple harmonic motion, and the simple harmonic motion of the spring is given by the time period of the simple harmonic motion is given by 2 pi under root m by k, wherever the spring is there. So we have to put this formula, and later on for the frequency we have to do 1 upon time period. So in this manner we have to proceed all the numericals relating to the spring balance. Okay, so thank you. So please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.